started talking about what is a fair bet. And from here, we also kind of picked up on what is a risk-averse individual. Now, what we will do is we'll pick up from this part where we were talking about risk-averse individual, and we'll go ahead and we will talk about how to go ahead and find out the risk premium and how to talk about something which is known as a certainty equivalent. Very, very important concept in the part of risk. So let's first understand the utility function that we had drawn in case of a risk-averse individual. This is the utility function that we had drawn for a risk-averse individual. What we had gone ahead and said is, let's suppose that I'm going ahead and I'm marking wealth here, and I'm marking utility of wealth here. So let's say that the wealth is 10 and the utility that the individual derives from 10, let's say that this is 70. The wealth is 70 and the utility that the individual derives from 70, let's suppose that this is given to us as 140. Now, supposedly, there are two events. Remember the example that I had given you the last time? The example was related to rain versus no rain. And we had said that if it rains, then it would be a failure because the person will not be able to arrange the event, in which case the wealth of the person will go down to 10. So if it rains, then the wealth is becoming 10. And if the wealth goes down to 10, then in that case, we will say that the utility that the individual get from this 10, this will be 70. And then we said that if there is no rain, then it is a success because the person would be able to play the game. And in that case, the wealth will be 70. This would be the wealth. And the utility from that wealth, that would be 140. So this will be the utility from that wealth. So utility from 10 would be 70 and utility from 70 would be 140. And now, suppose I tell you that the probability of rain is equal to the probability of no rain, which is half. So what is my expected wealth? My expected wealth will be half into it rains plus half into it doesn't rain. So my expected wealth would be half into 10 plus half into 70, which would be 40. This is my expected wealth. Now listen to me carefully. I am saying that if you play the gamble, if you gamble, then On an average, you will earn 40. Sometimes you will win. Win means there will be no rain, which means you will earn 70. Sometimes you will lose, in which case you will earn only 10. So you can win and earn 70, or you can lose and earn 10. You can either win or lose, but the average, on an average, you will make 40. Now supposedly, I tell you that, look, to play this gamble, you have to pay 40. So in order for you to go ahead and play the gamble, you have to pay 40. So this means that, just imagine, you as an individual, when you don't play gamble, then also you have 40 in your pocket. And you as an individual, when you play gamble, then on an average, you have 40. Here you have 40 for sure. Because if you don't play gamble, you're not investing this 40 rupees. And if you're not investing, the 40 rupees intact in your pocket. But if you're playing gamble, then in that case, you will have this 40. But you will have this 40 on an average. Sometimes you will have 70 with you. Sometimes you will have 10 with you. But on an average, you will have 40. Please understand the difference first. Now, the first kind of individual that we want to take is a risk-averse individual. This is the kind of individual when under both situations, when playing the gamble and not playing the gamble, when it gives you 40, then this individual gets more utility from not playing gamble. So please understand what I am saying. I am saying for a risk-averse individual, the one individual who does not like risk, for this individual, his expected utility from 40, which is coming with certainty, that means he is not playing gamble, it is coming with certainty, his utility, his expected utility from that 40, that is more. I am saying this amount exceeds his expected utility from the expected value, and this expected value is also 40. Please understand, this expected value is the expected return. My expected return by playing gamble is also 40. But the utility that I am getting from the 40 that I get after playing gamble is less than the utility I am getting if I get this 40 with certainty. That is the difference that is coming here. So basically, for him, his utility function, it looks something like this. This is how his utility function will look. And how do I show this? Let's say that I take 10 here. His expected utility from 10 is, suppose, 70. And I take 70 here. His expected utility from 70 is, let's say, 140. And now what I'm going to do is, look here, I'm going to go ahead and join these 2 points by line segment. And now here in between, I am saying, look, this is 40. This 40 represents two things. First, it represents the 40 that I have without playing gamble. If I don't play gamble, then I have 40 in my pocket. And if I play gamble, then I was losing this 40. But on an, so, you know, when I was playing gamble, there were two situations. Either by, you know, I had 40 in my pocket. When I played gamble, either that 40 became 10, I lost 30, or I gained 30 and it became 70. So either I would make 70 or I will make 10, but with a probability of half each. So when I play gamble, then also I earn 40, but I earn 40 on an average. This is by playing gamble. And I'm saying that both these things, whether you play or don't play gamble, one gives you 40 for sure and other gives you 40 on an average, but both are 40. Now, please see this. If I take this 40 to my utility function, the black line, and I extend it here, this is the utility you get from 40 with surety. And if you take this 40 to the line, then this line represents half into utility from 70 plus half into utility from 10. So this line dot represents your expected utility. And now I am saying that this is nothing, but this is the utility you get by expected value of 40, which means by playing gamble. Suppose I tell you, suppose, please understand, suppose I tell you that the utility from 40 is 120 and the utility from expected value of 40, this is nothing but half utility from 10 plus half utility from 70, which is half into 70 plus half into 140, which is half of 210, which is 105. So I'm saying this is 105. And let's say, suppose this is given to me in the question that this is 120. Suppose this is, I'm just making a fictitious number. Suppose. So what am I saying in this case? I am saying that the utility that I get from 40 that I have in my pocket without playing gamble, that is 120, and my expected utility that I get after getting this 40 on an average by playing gamble, that is 105. This is happening for a risk-averse individual. So he is getting more utility by not playing the gamble. He is becoming better off by not playing the gamble. Now please understand here. See, from here, we go ahead and we define something very, very important, and that is known as risk premium. So please write down the definition of risk premium first. It is the